Hello viewers, I welcome you all to my channel Brainiac's World. The video which we are going to discuss now is going to serve as a house building guide for a common man to construct up to G+3. That means ground plus 3 floors, or it can be 2 floors also, but maximum will be up to G+3. So let's proceed with the video. So in the first 2 to 3 slides, we will see the advantages, basically the comparison between a load-bearing structure and a frame structure. So it is usually used to show the advantages associated with the frame structure. So I would suggest all of you to go with the frame structure in place of more than G+1. So the basic steps is to first shortlist your needs, make your plan for the build area, while we at the Vastu, draft it in 2D, okay, followed by all the side views, which means elevated views, and afterwards the most important key is the placing of columns at the appropriate corners and junctions in the drawing. Make sure that you always do 4 columns in place of 3. Now there are 2 ways of achieving the problem, which you can see in the slide, followed by we'll see an overview or simply the roadmap how to achieve a project. First would be site leveling, marking the excavation area for foundation with of right angle triangle method at all corners, foundation finishing along with backfilling in brickwork up to Plinth level, raising the columns. In this process, make sure that the distance between any 2 columns should not exceed 15 feet. Also work on the thick tank and parallel. The next step is constructing the skin beam and applying the damp coats layer and raising the columns completely or parallel, followed by the brickwork and placing of doors and windows frame, after which the lintel beam over doors and shutters and windows along with corner beams inside rooms and kitchens for storage can be provided, after which constructing planning and all rooms is essential. Afterwards, upper floor slab with beams and taking care of electrical and plumbing at the same time, followed by you need to create a provision for overhead tank on the top floor. Staircase construction is also a very important step, after which we need to focus on plastering, taking of tiles, applying putty and painting, and the last step only we have to work on the wooden wardrobes, fixing of doors, all kinds of shelves, shelf doors of shelves, and so on. Basically, the load transfer mechanism is shown in this slide. Basically, it starts from the slab, the weight of the slab or the load from slab is transferred to beam, followed by column, and from column towards foundation, and then foundation to the ground. And you can also uh, observe the loading from each and every, you know, uh, the parameters that we considered, such as all rooms and kitchens, toilets, bathrooms, corridors, passages, staircase, balcony. The balcony is basically a cantilever. Okay, now the loading which can be observed can be calculated based on per meter or per meter square. Okay, and under these loads, they can be generally classified as dead loads and live loads, as you can see in the slide. So the first and foremost thing is that we need to lay a foundation in order to proceed with the other process of construction. Now for a G+3, I would suggest you to go with a shallow foundation having an isolated footing. Which footing can be of cuboidal shape or a trapezoidal shape. So first and foremost, need to find out the depth and width of the foundation by the appropriate formulas as shown in this slide. Okay, these are some uh, representations of footing called as simple footing, slope footing, and step footing. suggest you to go with slope footing or trapezoidal footing. Pad footing is also possible. If you are going for G+1, go with pad footing. But if you want to construct more than that, from G for G+2 or G+3, go with slope footing. And for 2 to 3 stories, roughly a width of 1 into 1 meter and depth of 1.2 meters up to 1.5 meters. For 2 to 6 stories, a width of 2 meters along with a depth of 1.5 to 2 meters can be used. The column orientation should remain such that the smaller dimension of the column should be perpendicular with respect to the longer side of the wall comparatively. And finalizing the columns, look for the irregularities encountered in the carpet based on column placement and or diagram. After the exclusion of the areas required for foundation and footing and determine solution for the exposed area and vertical holes, and we need to maintain the minimum steel percentages in slabs, beams, columns, as shown on the slide with appropriate values. And also we need to maintain the overlapping length of 45 degrees more than the physical diameter of the bone per column is the beam and 45 degrees construction tension zones in the beam with respect to cross sections, followed by okay, so this is a column design for a trapezoidal shape or slope. Followed by this is the bargaining schedule for it, assuming that the dimensions of this kind of machine is 2000 mm. That means 2 meters in x-axis and 1.5 meters in the y-axis. This is about the being schedule for it, and the total weight of the total amount of material required for it is also calculated over here. This is how it would look like after it is raised up to this level. So this is the diagram which would show column elevation for a step footing. It is nothing different to a slope footing. The only difference is that instead of having trapezoidal edge, we have a stepped edge, and this is the pedestal over here. In the previous slide, we showed the pedestal length till here, and from here onwards, the column actually rises. These bars will also have been picked over here, along with the pedestal bars. Same thing is shown here also, and this is the plinth level, or simply the ground level of the house. Remember, not the natural ground level. So here we have the cutting length of the rectangular stirrup with a clear cover of 40 mm. Let's say we have a cross section of the size for a column at 250 cross 450 with stirrups diameter 8 mm. Now here is the cutting length of rectangular stirrups. As you can see, there are 4 bars with 135-degree twisting. As you can see, this is one entire thing, and this is one entire arrangement. This length over here is A, this is B, and the space in between the outer covering and the stirrup is called as clear cover, which is 40 mm throughout. This is being done with a diameter of 8 mm. Okay, followed by okay, in this slide we have found out the values of A and B. Okay, here we have some more information on the volume of trapezoid, or the total volume of the entire footing itself. These are some of the values of clear cover, the different arrangements which are footing, column, beams, slab, breakers, checkers, nails, tripod, and so on. Okay, from bottom, sand filling is done for 3 to 4 inches. This is with respect to the development stages when constructing a footing. So initially 3 to 4 inches of sand has to be filled, followed by plain cement concrete or PCC bed. Again with 3 inches to 4 inches of M10 grade with 1:3:6 cement sand aggregate, and followed by RCC comprising which is called as reinforced cement concrete of approximately 1 feet thickness, about M20 grade, RCC of M20 grade IS 456-2000, with 1:1.5:3:0.5 of cement and aggregate when water is used. Afterwards, fill up the other parts of the volume until the natural ground level. Okay, with sand and the mentioned previous volume for RCC with the help of shuttering and filling process. Okay, as I told you, fill up the respective volume of the foundation like sand up to the natural ground level. After this, we need to uh, set the cross-sectional area per columns. Let's say for G+1 a standard size of 9 inches cross 9 inches having 4 bars with 12 thick bars only along the rectangular or square stirrups of size 8 having 6-inch center to center has to be used. So this is the formula used for finding the cutting length of stirrups. So this is how it looks like, and it is fixed over to the footing. This is the column arrangement. And these are at appropriate angles such as 0, 90, 180, 360, and also 45. This is 45 and 35, and so this needs to be fixed to the bottom of the footing, and then concrete needs to be poured in this volume, and the rest of the volume up to the natural ground level has to be filled up by sand. And one more thing, the topmost part of this column needs to be bent like this, such that it is connected to the slab above of the first floor. So the measurement of this much length is called as development length. It is of about 50D. So D refers to the diameter of the bar itself. This whole thing is represented as LD. For G+2, you need to use a standard cross section of the column as 9 inch into 12 inches, having 6 bars with 16 mm thick bars along 4 corners and two 12 mm bars in between with rectangular square stirrups of size 8 mm, followed by column cross section size for G+3 as 9 inch into 15 inch or 300 mm into 500 mm, having 6 bars with 20 mm thick only along 4 corners and 2 bars of 16 mm thickness in between the longer dimensions of the column with rectangular square strips of size 8 mm having 6-inch center to center or 4 bars along the longer dimension can also be used. In case of G+4 apartments, use 5 bars in the longer dimension side, or let's say 4 bars of 20 mm thick on sides and 116 mm in the middle. And the distance between the stirrups can be 100 mm in zone A and 150 mm in zone B for G+2 and G+3. Now as you refer to the diagram over here, the length from the topmost or the location where it is joined to the upper floor or G+1 floor, let's say, if we consider the distance from the top until L/6, so this zone is called as zone A. Similarly, from the bottom of the footing and up to a distance of L/6, again it is called as zone A, and the middle layer is called as zone B. See, zone B doesn't take up much load, but for these regions here and at the ends of about L/6 and L/6 is crucial because these things can start swaying in the case of earthquake or high-speed winds, and so on. So in order to prevent that, more number of stirrups are arranged in zone A and less number of stirrups are required in zone B with more spacing. Here less spacing is given but more stirrups. Here less spacing, less number of stirrups. Okay, and also the columns will be of bent up shape like this. In case of G+2 or G+3, the column bars or the bars of column are arranged in this fashion. Now as you can see, all these are bent ups are provided alternately. As you can see, it is given over here, but in the next one at the bottom it is given. Similarly afterwards, like it's subsequent to subsequent one, it is provided over here. So this is a typical example of the cross section of the column. The next is the brickwork part during the construction process. So we need to come up with 3 to 4 layers with 1:6 cement and sand and a plinth beam. It is not required, this arrangement is not required in hill stations or on natural ground level, and basically it is used to avoid flooding due to rain or road repair and even due to new layers of roads. So some apply DPC or deep-proof course with vitamin coating polythene sheet to avoid capillary action. So at this stage only, during the plinth level itself, some people apply DPC and few apply over the plinth beam and few apply after 2 to 3 layers of brick construction above the plinth beam. Basically use 9-inch width and 12-inch depth for plinth beam of G+3 for G+1 and 9-inch cross 9-inch having 4 bars of 12 mm with 6-inch center to center can be implemented. For G+2, a 9-inch cross 12-inch having 6 bars of 12 mm with 6-inch center to center can be used. But I suggest use 16 mm bars of 4 pieces with 8 mm thick bars for stirrups around bar arrangement with 6-inch center to center spacing for G+3. Apply anti-termite solution after filling sand and leveling the ground of house. Again, remember, I'm not referring to natural ground. After this, plinth beam in a frame structure is meant to join all the columns. The main function of plinth beam is to join all the columns such that it will not buckle and proper load transfer takes place. Followed by the rectangle cross section of column and beam can be replaced by an equivalent square beam also. So this is a concealed beam. In order to maintain proper spacing, this is called as concealed beam. We'll see in after plinth beam, the full section of the lintel level followed by the doors and windows frame out in their appropriate places along with door plan fixing. Thread lines and plumb bob are used to achieve the brickwork with 1:6 cement sand ratio. At lintel level, lintel beam is designed right above the door level, approximately 7 feet from the plinth beam level. Basically, lintel beam refers to chadjar. Room chadjars have a width of 1 feet to 3 feet with thickness varying from 2 inch to 4 inch. The main bars of the room chadjar are placed at 6-inch center to center and with thickness 10 mm. Similarly, distribution bars are also placed at 8-inch center to center with thickness 8 mm. Window chadjars have a width of 1 feet to 2 feet with thickness varying from 2-inch to 3-inch. The main bars of the room chadjar are placed at 6-inch center to center and with thickness 10 mm. Similar distribution bars are placed at 8-inch center to center with thickness 8 mm. For a 4-inch wall, 4-inch cross 4-inch tie beam having 4 bars with 12 mm thick with 8 mm thick stirrups of 6-inch center to center is used. Suppose if the wall thickness is of 9 inches, then 9-inch cross 9-inch tie beam for G+1 having 4 bars of 12 mm is used. For G+2, 6 bars are required with 8 mm thick stirrups of 6-inch center to center. Okay. Some more important points are like maintain the size of the main door as 4 feet cross 7 feet, parking door as 10 feet cross 10 feet, bedroom doors must be 3 feet cross 7 feet, size of the kitchen and bathroom door can be 2.5 feet into 7 feet, followed by so on of bedroom, kitchen window, kitchen ventilation, bedroom ventilation, bathroom ventilation, exhaust, bathroom exhaust, kitchen exhaust. So this over here represents the unit weight of bars for different diameters which we will implement in the construction process of a house. And this is how it would look like. The slab beam. This is the beam of upper slab. Let's say for G+1 or G+2, this is the slab over here, and these are the beams. So I will just continue the brickwork afterwards up to the slab and slab beam. It can be primary beam as well as the secondary beam with 1:6 cement and sand. This brickwork needs to be completed with 1:6 cement and sand. In case of beam, stirrups have to be only in the clean sand, not at the junctions of the beam and column. Never. And you have to avoid negative element. Use the L/3 the extra bars up to L/3 in case of continuous beam and L/4 in case of terminating beam with the two clear span. We will also find out the depth of the beam, basically the breadth and depth of the beam. For a particular length of the beam, we have standard equation such as B is equal to L/16 and B is equal to D/10. So let's say for a length of 5 meters, we get the depth as 1 Similarly, now to find the breadth of the beam, it is 20. Now the bent of bar resists the diagonal shear. Bent of bar in a beam can be avoided through the following: by putting extra over support bars, curtail bars, reduce spacing of beam in the support, which is L/4. In a slab, the bent of bar cannot be avoided. It is the must be. Bent of bar is also known as crank bar of flexural reinforcement. So as you can see at the bottom of the slide, it is showing a curtail bar which is always straight and which is in which the development length is shown by the symbol B1. For EOS bars is also shown in the diagram, which is depth minus 2 into cover. To in a beam, a bent of bar is going to that the take a slab is very fast. So with proper calculation, and suggesting that for a beam of up to 5 meters length, secondary spans up to 4 meters, wall loads of up to 8 kilometers per running meter, I can use D like below. Top steel having 2 bars of 12 mm, crank bars with 2 bars of 12 mm, crank at an angle of 45 degrees at a distance of 5/4 at both ends of the central supporting beam. With bottom steel having 3 bars of 12 mm. Now this configuration can change in normal factor. But try to maintain 9-inch width of beam in case of 9-inch width of beam, take 1-inch depth per unit feet of length of beam. So for G+1 minimum thickness of slab should be 5 inches or 1.5 and only 4 bars are enough. In case of crank bars, in case of G+1, G+2. So this is an example of a slab beam. As you can see, in which the appropriate spaces are maintained in the concealed beams, and all the bar types, sizes, number of members required, and how they are arranged is shown in the chart. Similarly, for G+1, some standard diagrams for a 9 cross can be a 9-inch cross 9-inch slab beam for G+1. For G+2, 9-inch cross 12-inch with 2 crank bars at an angle of 45 can be used. L/6, the distance of L/6 can also be used for small length beams. For G+3, make sure that the cross sections are 10-inch cross 16-inch. These are standard ones. With 2 crank bars at an angle of 45 degrees, crank bars should be kept at the distance of L/6. Top and bottom of crank bars all about 16 mm thickness. So this is the exact diagram of it. Here also we have the complete diagram schedule. So these are the views at the cut section X6 here. Similarly, this is the view of the cross section at YY. Okay, so this over here is called as clear span. The distance in between the supports or columns is called as clear span. And in here we see all kinds of designs of beams. So basically the parts of beams, simply the cutting length of parts. So coming to the base of slab, I recommend 5 inch or 125 mm thick because the slab contains flexible pipes embedded into them, which could be of 0.5 inches or more diameter, for internal line, which effectively reduces the slab depth at certain places, causing cracking, weakening, and water leakage during rain. So a minimum thickness of 5 inch should be needed. So these are different kinds of slabs that we come across at certain places. We are one-way slab, two-way flat plate, one-way joints the slab, two-way flat slab that drops, one-way flat slab, two-way waffle slab, skip joints or wide module, two-way beam and slab. Basically, one way, most important ones are only one-way slab and two-way slabs. In slabs basically, main bars are provided in the shafted direction. Main bars are also referred to as cranked bars or bent-up bars, and distribution bars are provided in the longer direction, which is straight bars in case of one-way slab. Whereas in two-way slab, main bars or crank bars are provided in both directions. Usually, two-way slab is adopted when the length and width of the slab is more than 4 meters. The thickness of one-way slab varies between 100 and 150 mm based on working configuration and span. The one-way slab is economical up to span 3.6 meters. The two-way bars can be replaced by a single dented bar. Remember, the old method of construction is to have two dented bars one next to another. But the newer procedure is like having only one dented bar having two cracks. Okay, the thickness of two-way slabs varies between 150 to 100 depending upon the span. The two-way slab is suitable and economical for the panel sizes up to 6 meters into 6 meters. So basically, the slab can be distinguished as one-way slab or two-way slab by a formula checking like Lf by Ly equal to 4:2 when we will consider 1 over one slab. With this value, if the ratio of this value is less than or equal to 2, then we are going to work it like a two-way slab. And also, the load transfer takes place in a one-way slab like this across the longer side. In case of a two-way slab, it takes place like this, trapezoidal with triangular fashion. So this is how it would look like for a one-way slab having bending moment across the longer length. So we could do the typical reinforcement on the one-way slab of circle bars and reverse bars. So as I told you, instead of making use of two bent-up bars like this one next to the another, we can make use of only one cranked bar such that it has a crank at this location and also a bent up at this location at 45 degrees with respect to the horizontal. Over here is a bar bending schedule required for a one-way slab of span length 8 meters and 3 meters. Size of 8 meters side length and 3 meters side breadth. I think this is the bar bending schedule of that. Followed by we have a two-way slab. The construction of two-way slabs is also shown over here with bending moment acting at both directions perpendicular to each other, and here we can see the bent up bar at both the directions. Okay, so this is the same diagram with respect to a coordinate axis. This length is taken as Lx, this is Ly. As I told you, Lx by Ly should be less than or equal to 2 to consider this as a two-way slab. And here we have the complete calculation for a two-way slab. and the output of this will be like we can find out the depth of the slab, the number of bars required, extra bar lengths, total length of the distribution bars, weight of the steel, total weight of the steel. The same thing can be done across y-axis also. You have to do it for x-axis as well as y-axis. And here comes the another important process, which is the placing of septic tank and water tank or overhead tank, followed by sump in it. And I would suggest always place the septic tank in the diagonally opposite direction to the sump in the ground floor. The size of 5 persons will be based on IS 24701963 as 12 into D into H is 1.5 into 0.75 into 1 into Q for 10 persons, 2 into 0.9 into 1 into Q. Okay, basically 135 liters of water is required by a single person per day. Okay, this is the water consumption by a single person. We can calculate the total number of liters required by a family. For a family of 81080 liters are required. Remember, these sizes are referred to septic tank. From here, we are discussing about the sump or overhead water tank. But basically, 135 liters refers to the amount of liter required by a single person, whether it could be due to drinking or washing vessels or washing clothes, or per person overall 135. Now we can calculate the total number of liters required by a family. For a family of 8, let's say 1080 liters are required per day. We have 1 meter cube as 1000 liters. So 1 liter equal to 0.001 meter cube. So volume of water is 0.0 into 0.141, which is 1.08 meter cube. Always remember that the private water tank has a capacity of 6,000 liters, which are transported by trucks or tractors. Therefore, for 6,000 liters, 6 meter cube volume is required to make a cubic tank. Take the cube root of 6, which is 1.81 meters. So the length and breadth of excavation will be 1.81 plus 0.2 plus 0.2. The depth of excavation includes internal depth of tank plus thickness of RCC floor as 1 is to 2 is to 4 plus a PCB base of 15 centimeter of 1 is to 4 is to 8 is maintained. Hence 1.81 plus 0.2 plus 0.15 can be measured. And also overhead tank placed on a brick platform or RCC platform for placing PVC tanks. Even an RCC tank with columns can be planned. Set the inlet, outlet and overflow properly. Always maintain a maximum distance for borewell and sump with respect to septic tank. Now, designing the water tank can be done by two methods. First one is called as approximate method and the other is called as IS code method. So I have described approximate method here in this slide, and here is a practical process of constructing water tank or a sump. As you can see, these are the diagrams with different views for placing bar and column bars at different directions so that the bed and also the walls of the sump can be constructed, followed by the types of materials required, the calculations required for it, the different types of views for different types of bar bending. Everything is shown in this slide. So this is the summary of the materials required for a sump and kitchen slab. Now we will see about kitchen slabs. Basically, modular kitchen can be installed directly or manually. Slabs can be constructed by the following procedure. Now maintain the height of the platform at 36 inches or 42 inches in case the walls are tall. The width of the platform can be up to 2 inch. Okay. In case of small kitchens, for big area 2.5 feet can be used. The width can be 2 feet. It is not 2 inches. There is a mistake. It is 2 feet. Okay. The thickness of the platform can be 3 inches made of RCC or something called as Kadapa stones or granite mostly made use of this marble. In the RCC platform, main rods of 10 mm thick at 6-inch center to center and distribution rods of 8 mm thick at 6-inch center to center is used. Now the size of sink can be 24 inches cross 24 inches. If it's for only a couple, then 24 inches cross 18 inches is enough. The bar bending is similar to Shedras with L/4 with the bottom bed length and the wall. So this is about the permissible stresses in concrete or calculations looking to resistance to concrete. So different grades of tank concretes with respect to direct tension, tension due to bending, and shear stress are shown over here based on the loads that are being transferred from slabs towards the beams, then onto columns, then onto footing to the ground. You can make use of different grades of concrete. And don't forget to use HYSD bars or TMT bars. Don't make use of MS bars. It is not required. Whole technique was to place or to use MS bar, mindful bar. Now everything has been replaced by HYSD bars or simply high yielding from bar, which is also called as TMT bar. The next step is plastering putty, tiles or granite polishing and painting. You can see everything basics and which are essentially shown in the slide. Don't forget to read them. Followed by the electrical plumbing and sanitary fittings. And all these are achieved by something called as chasing. CHASING, wall chasing. For this we get machine called as wall chasing machine for fixing electrical conduits and water pipes and follow the procedure. The last step is to fix the doors, windows for the house at various locations, followed by shelves, wardrobes, and interior. Now the methods of fixing the main door can be through column chipping or the room doors can be through column chipping, clamp fixing before casting, keeping holes before casting. Never make use of press method that is also outdated and it may due to this cracks may emerge. Cracks might occur in the columns. Okay, so that's why I never suggest you to go with method 1 which is called as column chipping. It is not recommended. You either go with the second method or the third method. And again I'm telling you to maintain the following sizes for a better look of it. Thank you. Don't forget to like, share, comment and subscribe.